My name is Paul Kelly, a Microsoft MVP with 30 years of software development experience. I've worked on numerous real-world VBA projects where I've fine-tuned the best techniques for writing Excel VBA. Here is 10 years of array knowledge that will help you write VBA code like a pro. Make sure to download the source code from the description below so you can try these techniques out for yourself. Arrays are crucial in VBA, so let's start with the basics and understand why we need them. Now imagine somebody gives us a simple application to write. We want to take the student marks in cell A1, we want to multiply it by 10, and we want to write out the result to C1. So how would we do it? So we start off by declaring our variable. We'd have a variable called marks, and that would be a long integer. And then we'd set marks equal to the value in the cell. So we say sh marks. Now if you're not sure what sh marks is, if we look into the left-hand side, what you'll see there is that we have sh marks, and then in parentheses we have marks. The marks in parentheses is actually the worksheet name, and the marks that we have, the sh marks, is what we call the code name. Now if we look in the properties window, and let me just drag it down a bit. When we click on the worksheet in the project window, the worksheet properties appear in the properties window. So we can set the code name here, and this means we can directly reference the sheet if the code is in the same workbook. So we can directly reference the sheet. And the real advantage is that if the user changes the worksheet name, our code will still work. So we directly access the worksheet like that. Then we use range, and we say A1 and value. And then we want to do something with marks. So we want to multiply it by 10. And then we want to write it back. So we write it back by saying C1 equals marks. So we'll equal the new value of marks. So we run this code, and you can see that it worked as we expected. Now this code is obviously very simple, and you might think it's a bit long-winded way of doing this, but it's very important because this is doing the basics of any data manipulation that we do in VBA. It's reading the data, and then it's processing that data, and then it's writing that data back. And this is what we do with most data manipulation applications. And obviously they're much more complicated than this one. So imagine whoever gave us the project comes along and says, you know something, we've got 2 more students and we want to measure their marks as well. And so what that would mean is that we would have to alter our code a bit. So what we could do is we could say dim marks is long, and we could create 3 variables. And then in this case, we'd say marks 1, 2, and 3, and they equal the values 1, 2, and 3. Now, rather than just typing all this out, let me just copy the rest of it in. So we run the code on, and you can see that it wrote out the values as we expected. Now, of course, our code has a problem. And the problem that our code has is that, first of all, we're using 4 lines of code for every variable that we need to deal with. So for every student mark, we need 4 lines of code. And if there was 100 students, then we need 400 lines. And the second problem is that our code has to be changed depending on the number of students. So if we had 100 students, we'd need to add all the lines of code in. And then if the next time we had less students, we'd have to remove the lines. So you can see both of those problems make it impractical to write code this way. So what we would do instead is we would create an array. So we have one variable, and that variable is our array. And so we can get rid of this one and this one. And so now instead of having marks 1 as a variable, we'd have marks and we have an index. So we'd have index 1. So we replace all marks with the index. And the same thing with marks 2. It's no longer a separate variable. It's just a different index in the one variable. And the same with marks 3. Now the index is also called a subscript. So you might have seen the subscript out of range error. And a subscript out of range error basically means that we're using a subscript or index that doesn't exist. So in our case, we have an array 1 to 3. So subscript out of range would be if we try to access anything outside of this range of numbers. And so we've written out this as an array. Now, of course, it's very kind of basic code, but the code still works. Now I'm going to just put some code here, and this will be sheet marks, range, and I'm just going to delete
the values in the output range.
So it's going to be C1 to C10. And what we'll do is we'll clear the contents. So we know that the data has been removed each time. So if we run our code, it actually updated as we expected. So it's doing the same thing, but our code now is using an array. So we've kind of solved a bit of the problem. We're only using one variable. But what we want to do is we want to cut down on the other lines as well.
To reduce the number of lines of code, we use a for loop. If you're familiar with for loops, you know that they work seamlessly with collections and arrays. Arrays allow us to easily manage groups of items, and the for loop lets us efficiently iterate through them.
So we would say dim I as long, and then we would say for I equals 1, 2, 3. And then we just use the I here as the index. And then we say ampersand I. And so the first time this will be A1, then A2, then A3. And we do next I. So we don't need these lines any longer. Now the same thing down here, we can just replace these lines. And we can just have one line in our loop. And we replace this with I and this with I. And again, the same thing down here. We just have our for loop and we replace this line here. We put I in here, so ampersand I to give us the cell, and this becomes I. And now our code is at a fixed size. So in other words, if we need to add any more students, our code doesn't have to change. It'll have the same number of lines. So this has solved the first problem, but it hasn't solved the second problem. And the second problem is that if we have a different number of students, so for example, if we add 5 students, so we've added 2 more here, now we have to adapt our code. We have to change the number 3 everywhere. So how we would deal with this is as follows. We do what's called, we find the last row with data. So let's do that. So we say dim last row as a long integer, and we say last row equals 2, and it's going to be sheet marks, and we want to get the last cell in the current column. So the last cell is A ampersand, and the last row number is simply sheet marks rows.count. And then what we do is we do a control up, which we do basically with end XL up, and then we do row, and that gives back the value. So that, just in case, if you've seen this before, it's actually pretty standard in VBA, but if you haven't seen it before, you might find it just a little bit complicated. So I'll just explain it very simply. We essentially go down to the very last cell, so that's A1,000,048, so on, and then we do a control up arrow, and that will stop at the first cell that it has data, and that'll be the last cell with data in the column. So that's simply all it's doing. And so the first part will give us back a range, and we can just use the row property to give us the number of that row. So now what we do is we basically say last row 1 to last row, and then we can use last row everywhere. Now there's one problem with this, and that is that dim doesn't allow us to use a variable. So what we use instead is we use readdim. So readdim is basically redimension. So in other words, we set the size of our array. So that means in our dim line, we still declare it, but we basically say this is going to be an array and we're going to set the size later. So we don't give it any size. And then later we set it to be last row. And then we can just use last row everywhere. And now if we run our code, it should, if all has gone well, deal with 5 different data items. And you can see that it has. So let's delete 2 of these and let's run it again. And you can see now that it copes with that as well. So now our code is getting better because it's now able to solve the 2 problems. No matter how many students we have, the same code will work all the time. So this code is much better than what we had before. And you can see the benefits of using an array. So now one more thing that we should point out here is that when we're going through the for loop, we're using last row. And what this means is that anytime we use the array, we have to go back to find last row. We have to say, well, how do we get the size of the array? And now we need to use that variable when we're reading through the array. So that would be very complicated and a bit really unnecessary to do. So instead we use the 2 functions, L bound and U bound. So L bound marks will give us the first position of the array, and due bound will give us the last. So in other words, it'll give us 1 and 3 in the case where we declared an array as 1 to 3. So the beauty of this is that we get an array, we don't really care the origin of the array. As long as it's an array, we can get the start and end position using L bound and U bound, and that makes our code very flexible. And so this is kind of the basic code. And we're going to update this code and make it much better in a second. So don't worry if you think it's a bit kind of overkill at the moment.
A question that I get asked constantly is, how can I write better Excel VBA code? Being able to write good VBA code will save you a lot of time and frustration. On this channel, I've given a ton of tips, a ton of techniques, and a ton of example code you can use in your own applications. I've decided to aggregate all of that into one simple course so you can access it in a step-by-step manner. You can learn the techniques and principles that I use on a daily basis, and you can take my optimized code and use it in your own applications with a simple copy and paste. You can check it out in the link below. Alright, now back to the video.
Now, the problem that we have with this code is that we've got 2 lines here. So this line is reading from the range, and this one is writing to the range. So if we have 1,000 students, we would be accessing the worksheet 2,000 times, and that is a problem. And the reason that that is a problem is because when we're accessing the range, it's actually very slow. So it's like we have a dirt road, and each trip that we go to the worksheet is slow. So if we want to have fast code, want to have our application running quickly, it's important to understand this. Now, if you're dealing with a small amount of data like we have here, it obviously doesn't make a difference. But if you're dealing with a lot of data, it's really important. And one thing to keep in mind is if you're building a big application, that application can grow in the future, and you might be doing multiple processing, and then it can start to slow down.
And what that means is that you would have to go back and rewrite the code in the application.
So processing arrays, as you can see in the image here, in comparison, it's like that you're on a really fast, clear road, and it works much faster. So recently someone had a problem with code. It was taking them 6 hours to run. And when I changed it from ranges to arrays, it basically got down to almost instantly to just a few seconds. And that is the difference. So I think they were processing something like 100,000 records, but they were reading various fields on the worksheet. So in each row, so it was probably 300, 400,000, and it was taking a huge amount of time to do different processing. So what we essentially do, rather than every time reading a value from the worksheet, what we do is we take all the values in one go, and we'll look at that in a moment, and we place them in an array. Now, when we do this, it's important to remember that we're just copying the data to the array. So if we change the data in the array, it doesn't affect the worksheet. And when we're finished processing in the array, we write it out to the worksheet. And that's when it gets updated. And again, we're just copying the data from the array in memory to the worksheet. Now, in some cases, which we'll see later when we're filtering data, we might have a second array to write out. So we process the data in the original array, then write out the results we want into another array, and then we'd write that to the worksheet. But in either case, we're still only accessing the worksheet on 2 occasions. And that makes our code very, very efficient. And now what we want to do is we want to upgrade this code. So the first thing to understand here is that we've been using a one-dimensional array. So you might hear one-dimensional, two-dimensional, and it sounds complicated, but it's actually quite straightforward. So I'm just putting a breakpoint here, and when I run the code, it'll pause here. So we're going to look in our locals window, and the locals window simply allows us to look at variables that are currently in play. So marks, for example, here you can see the plus beside it. And if you click on the plus, what you'll see is that we've got 3 places. We've got 1, 2, and 3. And they're all set to 0 at this point. Now, if we just step through the code, you can see now it's written 85 to position 1. It's written 34 to position 2. And it's written 56 to position 3. And so this is a one-dimensional array. It's just one list of items. So a two-dimensional array is basically rows and columns. So in other words, it's simply a worksheet in memory. So in a minute, we'll have a look at that so that you can see the difference. So we've all this code here to fill our array. So we basically have to declare our array. We've got to set the size of it, and we've got to figure out what the size is. And then we've got to fill it up. Now imagine we could get rid of all this code. And the thing about it is we can, and that's the beauty of VBA. So we can actually say dim marks as variant. So a variant in VBA is basically a variable that we haven't given a type to. We're basically saying we'll give it a type later. Now, in general practice, it's a bad idea to do this, but it's fine to do it in this case where we're creating an array. And we simply say marks equals, and marks will equal cheat marks A1, and we will say last row. So last row, and that's A1 colon to A, whatever the last row is. And this will actually place the entire value here. So all the values get placed in mark. It actually resets the size of the array and fills the array for us. So we don't need any of these lines of code. So that's one real kind of advantage in VBA. It's one really cool feature. So let's put a breakpoint here. Let's run the code. And yeah, I deleted the dim I line. So I'll just put that back. Let's run the code again. And let's look in our locals window. And what you'll see in the locals window is that we've got marks. But when we open marks, you can see that it's got the rows, and each of the rows has a plus. And that's because we've now got rows and columns. So you can see position 1, 1, row 2, column 1, and row 3, column 1. So when we access them, what we have to do is we have to use row and column. So we have I1 equals I, comma 1. And we write out the array. The beauty is we can write out the array in exactly the same way. We can say C1 to C ampersand last row equals marks. Let's run the code on and let's look at our result, and it actually wrote out the values as we expected. So our code is much neater now. We don't have all the for loops. We just simply read the data out like this and we write it back. So we're going to improve the code even further. And what we're going to do is we're going to look at current region. So rather than using this last row, if we use this in the case of two-dimensional data, what we'd need is a last column as well, and then we've got to build a range, and it's quite messy.
So let's remove the data in column C for a minute, and let's imagine our data look like this.
So we've got rows and columns.
And we're going to write out the results to the columns D and E.
Now what we would do instead of last row and having all this is that we can just simply say A1 as the range, and we'll just say, give me the current region. And then we don't need last row anymore. So let's take a look at what that means. So if we have data like this, and we do current region. So current region in Excel is Control asterisk. So that can be Control Shift 8 on most keyboards or Control asterisk on the number pad. And what that does is it selects
all the adjacent cells that have data.
If we do it here, you can see that it selected all the adjacent data. Now, if I have data over here, it won't select any of this data because this data isn't adjacent. So it's not connected. So it's not touching it. But as soon as we add something that touches it, like this, they're all connected. So when we do current region, it gives us back all the data because it's adjacent in cells. Now, if we get rid of this one, again, it will just give us this section. We generally don't have to worry about the kind of complexities of it so much because most of the time we use it when we're dealing with rows of data. So when we have data in a nice row record format, it's very, very useful. And current region will always give us back a rectangle, basically, of data. So when I use current region, it's going to give me back all this data here, and it's going to put that straight out to our array. So that's really useful. Now, when we write out, now we can't use last row down here. We have to set the size to equal the size of our array. So if I say D1, for example, and write it out,
you can see that it only wrote out the first element of the array. And this is because it's simply writing to the range that we supply. So we've got to set the range to be the same size as the array.
And what resize does is basically it resizes the row and the column. So we'll say row count, and we'll say column count. And then we'll declare these as variables, and they're both longs. And then we'll set them to be whatever the array size is. So the array size we saw already is U-bound, and we say marks. Now the default is the first dimension, but I'm just going to put in 1 because we're going to be using the second one. So the default is 1, and this will give us the rows in a two-dimensional array. Now in most cases, this will be fine. If we have an array 1 to 5, this will give us back 5, and that means there's 5 items. But it is possible that an array can start in position 0. So we've got to be careful about that. And for that reason, we use this simple calculation. So it's U bound minus L bound. So the last position minus the first position and plus 1. So in other words, if we had an array 1 to 5, it would be 5 minus 1, which equals 4. And then we'd add 1 on to give us positions 5. And if it was positions 0 to 5, that would give us back 5, and we'd add 1 on to get 6 positions. Now, column count is almost the same. The difference is that it's the columns we're reading, obviously. So we get U bound 2. And we want to just update this as well. Now, don't worry if this is long-winded, because we're going to make it much easier in the future. And what we do then is we want to clear the contents, and we want to get the current region. So we want to use the current region to do this as well. So we'd say D1, and we're going to say current region, clear contents. And then we'll run this code and see if it works. And you can see that the code worked perfectly, as we expected. So we've upgraded the code a bit so that we're using current region now, which makes our life a lot easier. And down here then, we're using current region to clear the contents, and then we're building the size of our output. So what we want to do is we want to upgrade this code and just make our life a lot easier. But before we do that, let's have a look at a real world example. We have sales here. And what we want to do is we want to read all the records, and we want to multiply the amount by 10. And what we want to do then when we multiply the amount by 10 is write out all the records here.
This is a simple application with many approaches, but we're going to use the basic structure, which you can use in all data-related applications.
So now let's go to the code, and let's copy this code here, and we're going to use this in our sales example. So we paste the code here, and what I'm going to do is I'm going to just change everything that says marks, and I'm going to change that to sales. And that should actually work because I've been consistent in my naming. So that should work for a lot of what we're doing. Now we obviously have to change some of the ranges. So the range we're writing out to is actually F. So we're going to write the data to F2, and we're going to do current region on F1. Now, so when I run this code, what happens is I'm going to run into a problem, and we'll see what the problem is. So let's run the code, and we've got a type mismatch. So the problem that we have is, if we look in this one, is that this has amount, so it has day. So we're trying to multiply 10 by a string, which is a problem. But the reason that that's a problem is because we got the current region and it gave us the header, and we don't want the header. So what we need to do is we need to adjust this line a little bit. Now what I'm doing, it might look a little bit messy, but don't worry, I'm going to make this code really nice and neat in a few minutes, but it's important to understand kind of the background behind it. So what we do is we declare a range as RG as range, and we set that range equal to, and that's going to equal to this. So that's going to equal to the current region. But what we want to do is we want to change our range. So how we do it is, imagine this data that we have here. So we've done current region, we've got all the data, but the problem is we have the header. Now we can move the whole range down 1 by doing offset. That will move it down like this. But now you can see we've got a blank line on the end. But what we can do is resize the range as we've done already, and it should be resized to its current size minus 1, and that will give us this. So that might sound like a lot, but it's actually very simple to do. We just say offset 1 and resize, and we're resizing to the current size, which is rows.count minus 1. And we're placing all that into our array. So let's see if that works. We run the code, and you can see it does work, but we wiped out our header. And that's because we have to change our header code. Now, one thing I didn't change as well is that I'm multiplying the first column by 10 rather than the fifth one. Let's copy this again, and let's paste it in here.
So we add 4 here and here.
And secondly, when we're writing out the data, the problem is we're doing F1, we're doing current region, and we're clearing the contents. So after current region, we should use offset here as well. So offset will simply move the range down 1 so that we don't wipe the header. And it doesn't matter, we have a blank row at the end, but we don't need to resize because we're just clearing the contents anyway. So let's run our code, and then let's check our output, and you can see this time it wrote the output correctly. So let's delete some of these just to be sure, And you can see that it wrote out all the data as expected. Now the code you might think is a bit long-winded, and that's because it is a bit long-winded. So let's make the code a bit better. I have got simple utils here, and it's called get current region.
We can replace this code we have just written with a one-line call to this function. This function also has an optional parameter in case our header size is more than one row.
So for example, instead of this code, we can just say sales equals get current region. And this is my range. And my header is 1. So I don't need to actually supply the parameter because the default is 1. And then I can get rid of all this code. So I don't need this, this, or this. And again, let's run the code. Now again, I'm just going to delete some of these manually just so that we can see it updates.
And you can see that after those code changes, it still works correctly.
And so this looks much neater. Now down here as well, you can see that down here is a bit ugly. So because we're doing this all the time, a good idea then is to create a sub to do it. And this is the sub I created, which is called array to range. Now you might think it looks a bit complicated, but again, all these are optional parameters that I have here apart from the first two. And the optional parameters
allows for configuration in specific cases, but most of the time you can just ignore them.
And so what we can do then is we can simply say call array to range, and that takes an array, which is sales, and that takes the range, which we're writing it out to, and that is range F2. And that's all we need. And then we don't need to kind of figure this all out again. And now let's run our code. And again, I'm just going to manually delete stuff. And you can see that it wrote everything out as expected. And our code is much neater. So you can use this code here as the foundation for any type of processing of data that you do in Excel VBA. Now, it's rare that you're going to write out the same data as you read, but this is like the basis for anything that you want to do. And so we're going to look at a filter example, which is more along the lines of a more real world kind of thing. And then you can see from that how we can take this code and adapt it to it. But before we do that,
first we need to understand the correct way to pass these arrays as parameters. I was doing this the wrong way for a long time, and it was only when I read about it in an advanced Visual Basic book that I realized where I was going wrong.
So imagine we have an array here. Now this function, array function, in case you're not familiar with it, is actually a very simple function, and it just creates an array. Now it's useful for testing or for demonstrating stuff like I'm doing here, but it's not really something we'd normally use in a real world application. But anyway, we've created an array of numbers, and in an array of numbers, what we want to do is update it somehow. So we have a function that's going to update it, and this function will return our array. So we pass it in. So we say by val numbers as, and that's a variant, of course. And then we're going to update the data somehow. And then we're finished updating the data, we're going to return it. And then basically here, what we'll do is we'll say numbers equals to update array, and that'll take numbers. Now, actually in here, I'm going to call, just to avoid confusion, I'm going to call this one array. So it's just called array within our current procedure. So let's replace all in our current procedure. Now this code seems pretty straightforward, but actually it is a problem. And the problem is this: when you assign an array to another array in VBA, it's actually copying the entire array. So for example, if I said new array as a variant, and I said the new array now equals to numbers, but what actually happens is it creates a copy of this array. So now we've got two arrays. But imagine that you have like 100,000 items in your array. You can imagine how inefficient it is that if we're copying data around like this. So the problem is that when we pass something by val, it's actually creating a copy of the array. So it creates a copy of the array, and then when we assign it here, it actually creates another copy of the array. So it's actually happening in this case. If we had 100,000 records in an array, we're actually updating 200,000 pieces of data. And imagine we call this 10 times, for example, in our application. Now we're updating 2 million pieces of data. And you can imagine that this is a massive performance hit. So what we do instead is we use by ref. And by ref, what that does, rather than copying the array, it basically says to VBA, here is the address of the array, and you can go and use it. Now, it's all done under the hood, so we don't have to worry about that. All we need to do is give it by ref. And then VBA will know to access the same array. So when we do this, obviously, we're not going to use a function because we're not going to be passing back a value. And so we don't need a return value. And we don't need this line either. And actually, we don't need this line either. So we just do a call. And that will save us a lot. Now, if we just want to see, for example, this in practice, so let's say array 1, and that equals all these ones. Okay, that's too many, but let's just say this amount. So let's run the code. Let's look in our locals window. And you can see that the numbers array has changed. So we've changed it in update array. We've changed it in here, and you can see that it's changed outside. So now let's make this by val. And as I was saying, by val will just create a copy of the array. So it won't be updating the same array, just the copy. And because we're not passing it back, we're not going to get the new array. So we run this, and we can see when we look in numbers that our original array hasn't been changed. So because we passed by val, it created a copy. So it's very important to understand this in your applications if you're using arrays, that anytime you assign an array, you are basically creating a copy, and that can have a high performance cost. So always use by ref when you're passing an array. Now, if you're passing a standard array, VBA will actually give you a syntax error if you don't use by ref. So for example, so imagine this accepts an array of type long, so an array in this kind of format. Now you see I got an error. Hold on. Now I just have to turn on my auto syntax check because I have that off by default. And so when I enter that line, it basically gives me the error array argument must be by ref. And that's why, because it's just inefficient to use by val. But the problem is when we use a variant, then VBA doesn't know until runtime what it is. So that's why we don't get that error. So just one thing to keep in mind. So now what we're going to do is we're going to look at the filter example. So the filter example is really useful, as it's like I said, it's like the basis for a lot of what you do in VBA. The person who gave us this application came back and said, yeah, the application is really cool, but sometimes I just want to see what individual people, what their sales looks like. So whatever's in K1, that's the only results we want back here. So we say, yeah, no problem, we can do that. And we'll say, let's take this existing code. We know that does a lot of the job already. But what we want to do now is we just want to write back a certain amount of data. So let me just delete this and just explain what we need to do. So if we have an array, so imagine this is our array, and imagine this is in memory, because it will be in memory when we copy it. So just imagine this is in memory. Now, what happens is, when we read through this data, we'll basically say, is the first one Bill? No, it's not. We go to the second one. Is the second one Bill? So the second one is Bill. So what we want to do is copy this row. So we basically say, I want to copy row 2 to position 1. So we copy row 2 to position 1 in our second array. Now this is all happening in the array. We'll eventually write it out to the worksheet. And then we keep going, and then we get to 4, and 4 is Bill. So we're saying 4 goes to 2 in the array, and so on until we're finished. And when we're finished with our array, we'll write it out to the worksheet. So how we do that in the code is as follows. First of all, we would have to say if sales I2, and if that equals salesperson, we want to do something. And what we want to do in this case is we want to copy the row. Now, what is salesperson, you might be asking? So salesperson is a variable that simply stores the salesperson. So salesperson is string, and salesperson equals. Now that's why I turn off syntax check. So if you're using VBA a lot, you'll turn off syntax check because you don't really need it. And we say salesperson equals, and that's going to equal to our sheet sales, and it's going to equal to K1 and value. And now we've got this, we're checking it out here. So what we want to do when we're copying a row, we want to somehow take sales, we want to take the value out of sales and copy. And we want to copy each value. So we want to copy each item. So what we do is we use a for loop here. We say for j equals, and j will equal L bound to U bound. But remember that we're doing the column, so we're reading through the column, so it's actually column 2. And this one should be column 1, just to make it consistent. It doesn't need to be, but just to make it consistent. And then as we read through this loop, we're basically saying the current row and each one of the fields we're going to write out. Now let's declare our variables here, j as long, and we should have, and what we want is we want to have an output array here. So we want to have some kind of output array. So we would have output array like this, j, which is the column, and it's going to be the current row. So what is the current row? Well, the current row, as I said, is we just have to track each row. So the first time in our array, it's going to be 1, then it's going to be 2, and so on. So let's do dim current row as long, and then we say current row equals 0. Now the colon here basically joins 2 lines. So this is the same as this. It's just I use the colon to put them on 1 line just to make it neater. And in some programming languages, you can actually assign like this, but it doesn't change the functionality, but it just makes the code neater. Now the first time we find an item, we add 1 to current row, and that makes current row 1. The second time we find an item, we add another 1, and then current row will be 2, and so on. And so in our output array, we're going to be copying just the row, just like I showed you on the worksheet. So we need to obviously have an array. And to have the array, we basically say dim output array as variant. And this is going to be the same size as our original array. So we say basically L bound to U bound, comma, and then the columns are L bound to U bound 2. Now this, because it's going off the screen here, we can actually do the opposite of the colon. We can do space underscore, and this allows us to put basically a long line and split it over as a number of lines. Well, 1 line, basically every underscore, space underscore is 1 line. We could keep going if we wanted. So just to make the code more readable. So we've set the size of our array, and we're basically filling our array, the row of our array here. And down here, what we want to do is we want to write out our array. And let's go down here and let's run this code and see what happens. And you can see that it worked perfectly. Now, let's try it with someone else. So let's try it with John this time. And we run the code and you see it worked with John. And you see that it's already deleting the existing data and it's keeping the header and so on. So it's doing a lot, even though it seems quite simple. Now, of course, again, this code is a bit long-winded, so we can make it a bit neater. And I have a function here, and that's called array set size. And all it simply does is basically it sets the size of the array. So we do call array set size, and then our destination array, which is output array, and our source array, which is sales. So it's essentially this line here, but just a bit neater. And then at the end, when we're copying the row, I also have a sub called copy row. And so if we look at it here, what you will see is that we have array copy row. And that basically just takes the destination array, the row of the array that you want to copy it to, then the source array and the source row, the row that you're copying from. And how it works is we just say call array copy row. And then we're basically just saying destination array is output array. The row is obviously current row. And the array that we're reading from is sales, and the row that we're reading from is I. So we don't need this either. So let's save that. Let's do a debug compile. And let's change the name to Jenny just to see if it worked. And when we run the code, you can see that it worked just as we expected. So let's try it with Bill again. And you can see that it worked perfectly. So this code, even though I know there's different ways we can do filter and so on, this code is like the basis for a lot of what we do in VBA. So a lot of data manipulation in that we read the data, we put the output in another array, and then we write the array out. Now there's one other thing we should do here. I'm writing out the entire array, but actually we don't want to write out the entire array. We just want to write out the number of rows that we've got, which is basically current row. So the current row position. So you can see that the third parameter here is number of rows, and by default it's -1. So that if it's -1, we just write them all out. So we can actually specify this as current row. So this is more efficient if we had like 100,000 records and we only wanted to write out 10. So say we filtered and we'd only got 10. We don't want to write out the entire range, of course. So we've almost got everything, but there's one really useful thing we're looking at, and that's it. Imagine we wanted to sort by the amount. Now, in the old days, we'd have to look on the internet and get a sort function for the array because it doesn't have one, or we'd have to sort it as a range. And that's fine if it's your final data and you want to do it, but sometimes you might want to sort the data, then do something else with the data, and so on. But we can use the worksheet function sort. So we can say output array equals to the worksheet function, and that is sort. Now you can see here, VBA doesn't really help us. It takes argument 1, 2, 3, and 4. Not really that useful. But actually, we can just go into Excel itself and just say equal sort, and then just basically look at the help. And so if we look here, what you can see is that it takes an array as a parameter, and then it takes the sort index, which is the field we sort on, and it takes the sort order, which is like ascending or descending. And we can do a by call if we want, but we don't really need that in most cases. So obviously our array, we want to sort on column 4, and we're going to sort in descending, which is 1 for the moment, or ascending. So let's run our code, and then we look here, you can see that it's now in ascending. Now, of course, most of the time we want to do it in descending, so we just change this to -1, and we run, and you can see now that it's sorted in descending order.
This is the final code for filtering the data. If it seems overwhelming, remember that this code serves as the foundation for most data manipulation tasks you'll encounter. You can download a code from the description below and try it for yourself and use it in your own applications. To learn how to write high-quality Excel VBA code, sign up for my effective Excel VBA course today. The link is provided in the description below. I hope to see you on the next video.